if you have a 2 by 2 matrix, then its determinant denoted by determinant of this matrix, also denoted by this notation A11, A12, that is equal to the product of these two elements minus the product of these two elements, that is A11 multiplied by A22 minus A21 multiplied by A12. So determinant of a 2 by 2 matrix is given by this expression. For a 3 by 3 matrix, what is its determinant? This determinant is equal to A11 multiplied by, so determinant of a 3 by 3 matrix is given by this expression. This first entry over here, first element, multiplied by this 2 by 2 determinant of a 2 by 2 matrix, which is obtained by omitting the first column and first row, minus A12 multiplied by determinant of a matrix, which is obtained by omitting first row and second column, plus A13 multiplied by determinant of a matrix, 2 by 2 matrix, obtained by omitting first row and third column. So where these 2 by 2 determinant of 2 by 2 matrices can be computed in this way. So we call it expanding the determinant by first row. We can even expand it by second row, by third row, or even by columns. For example, so this is how we define the determinant of a 3 by 3 matrix. So please compute the determinant of this matrix. Minus 12. So some of you have computed it. So you know how to compute the determinant of matrices. In general, if you have an n by n matrix, then what is the determinant of that n by n matrix? These things over here, these are also named as minors. These are named as minors, and if you append this sign also, here is positive sign, negative sign, positive sign, then these are called cofactors. So for a general n by n matrix, its determinant, we can use any row or any column to expand this determinant. So if we use, for example, the jth row to expand the determinant, then what we shall get? We are using the jth row. So what we shall get? Here is some jth row. So first, what is first element of that row? aj1 multiplied by a cofactor cj1. How do you obtain cj1? We shall discuss it. aj1 plus this cofactor plus what is second element in this row, jth row? aj2 plus multiplied by cj2 up to ajn cjn. If we expand by jth row, if we expand it by, for example, kth column, then what we get? We can expand this determinant by any row or any column. If we expand it by kth column, a1k multiplied by c1k plus a2k plus 2k multiplied by C2k up to what will be the last entry in the kth column? A n nk C mult nk. Sorry? These are being added, so just compare it with the situation of 3 by 3 matrix. So we had for 3 by 3 matrix, we had this entry multiplied by its cofactor, this entry multiplied by its cofactor plus this entry multiplied by its cofactor. Determinant is always a scalar. Determinant for a matrix, here D is determinant of this matrix, which is always a scalar. What are cofactors? Cofactors are given by this dimension of this matrix is n by n, n by n. Determinants are defined for square matrices. So number of rows is the same as number of columns. So if you have, for example, 3 by 3 matrix, this matrix, if you expand it, for example, with the second column, so what is k for that case? K is equal to 2. You just want to use this relation A1, so that is this multiplied by cofactor corresponding to this element A22 multiplied by another cofactor A32 multiplied by another cofactor. So you can expand the determinants either by rows or by columns, where these cofactors Cjk is obtained by jkth cofactor is obtained by minus 1 to the power j plus k multiplied by mjk. Mjk is the minor, and how do we obtain this minor? Minor mjk is the determinant of a matrix obtained from this matrix by omitting jth row and kth column. So mjk is determinant. So mjk is determinant of the matrix which is obtained from this matrix A by omitting its jth row and kth column. For example, over here, what is M32 for this matrix will be obtained by determinant of a matrix which is obtained by omitting third row and second column. So third row is this row, we omit this row and second column. So determinant M32 is A11. So that you already know. However, the only difficulty is that we are writing it in a general way for general n by n matrix. So is it clear? This approach to compute the determinant of a matrix involves more computations. When you find determinant of a matrix using some computer program, you will have to perform more number of multiplications and additions. We shall learn another approach to find determinant of matrices which involves less computations. We shall talk about that in a later lecture. Here we discuss the Cramer's rule. We have system of equations. We can write this system of equation into a matrix form. So Cramer's rule states that the solution to this system of equations is can be computed from this relation x1, provided that determinant of matrix A is not equal to 0. If the determinant of matrix A is equal to 0, then we cannot use this relation. So Cramer's rule states that for system of equations given by this matrix form, x1 is obtained by determinant of this matrix. What is this matrix? This matrix is obtained by replacing the first column by the right hand side, and this determinant is obtained by a matrix by this matrix by replacing this column, second column, by the right hand side. So you can easily find the solution to system of equations by using this determinants. So please find the solution to this system of equations. Find the solution to this system of equations using Cramer's rule. Cramer's rule is, we have learned another approach to solve the system of equation, that was by reducing the augmented matrix into echelon form. That is more practical approach, involves less computations. This approach, the Cramer's rule, involves more computations. You have to perform more number of multiplications and additions. However, sometimes for hand calculations, it is more convenient. For hand calculations. For computers, this involves more number of computations, because computation of determinant by this approach, that is not cost effective. So have you found this? Have you found the solution? So everyone has found the solution to this system of equations. So for a system of equations with n unknowns and n equations, how we can extend that thing? So you will have this matrix A. Then how do you get x1? x1 is obtained by this determinant A, and then this determinant d1. d1, so let me use the same notation, d1 divided by d, where this d is determinant of matrix A, and d1, what is that? d1 is determinant of a matrix, this matrix, with first column replaced by the right hand side. Similarly, x2 is equal to d2 divided by d. This d is determinant of this matrix. d2 is determinant of a matrix which is obtained from this matrix by replacing the second column with the right hand side, and so on. xn is equal to dn by d. dn is determinant of matrix which is obtained from this matrix by replacing the last column by the right hand side. So this Cramer's rule is not cost effective. It involves more computations. So computer programs do not use this approach, they use the earlier approach. However, for hand calculations, this is sometimes more convenient. Two conditions when this matrix is square matrix, that is the number of equations is the same as number of unknowns, and second condition is that this determinant is not equal to 0. If this determinant is equal to 0, then you cannot use this approach. So only this approach is utilized when there is a unique solution. for the system of equations. Yes, please. Determinant के meaning, for example, for this matrix 1, 2, 3, 4, this determinant is the area of a rectangle formed by these two vectors. What is this vector? 1, 3? 1, 3. What is that vector? Let me write the simpler one, rather, which makes the rectangle. It is a parallelogram. So determinant is the area of a parallelogram. So let me first talk about the simple case. So what is this vector? 1, 0 is this vector, and 0, 1 is this vector. So here determinant is the area of this rectangle, in this case square, right? So 1 multiplied by 1. If you have another parallelogram, 1, 3 and 2, 1, let's say. So what is that determinant? 1, 3. What is that vector? Here is 1 and 1, 2, 3. So this vector is 1, 3. What is vector 2, 1? Here 2 and 1. So determinant of this matrix is the area of this parallelogram. For two-dimensional space. For three-dimensional space, when we have 3 components, then it will be volume of a cuboid. In 4-dimensional space, then you cannot visualize that thing. That will be something similar to cuboid in 4-dimensional space. You cannot visualize that thing.